To find the sum of the first n terms in a geometric series, we have a formula here. Notice to use this formula, I only really need three pieces of information. I need a1, which is the first term in the geometric sequence. I need the value of r, which is the common ratio. And I need the value of n, which is the I'm going to get from the index right up here. If you only have a few terms that you're trying to add, it's okay if you just find all the terms and add them together. Our example here, I have I going from 1 to 5. That's 5 terms of this geometric sequence. If you want to just find those 5 terms and add them up, that's okay. However, we have this handy formula. We're going to use that. A1 is the first term in the sequence. So A1 happens when I equals 1. 3 to the first power is 3 times 5 is 15. So A1 is 15. Next thing I need is the value of R, my common ratio. Well, that's the thing that's getting multiplied over and over in my geometric sequence. So it's the one with the exponent on it. My value of R here is 3 for this particular sequence. And then I need n. How many terms do I have? And that comes from right here. N is 5. Now that I know those three pieces of information, I can evaluate this geometric series. So A1 is 15 times 1 minus R is 3, and I want that to the n power. Well, n is 5. Yes, that's going to be a negative number, but that's okay because now I need over 1 minus R. 1 minus 3, that's also negative. So I'm going to divide a negative number by another negative number. It's positive, everything's good. Nothing left to do but evaluate. Well, let's see. 3 to the 5th power is 243. So I have 15 times 1 minus 243, which is negative 242, divided by 1 minus 3, which is negative 2. But those are just numbers. Put them in a calculator. That's definitely what I did. Our grand total is 1,815. So the sum of the first 5 terms for that geometric sequence is 1,815, and we didn't have to do too much work there. We just needed those 3 little pieces of information, put them in the formula, and we're done. If you notice, A1 is 15. If I let I count up to 2, then I have 3 squared is 9 times 5. A2 is 45. That's bigger. If I let I go to 3, I'm going to have a bigger number. So when I add the terms of a geometric series and my common ratio is more than 1, those terms are just going to get bigger and bigger and bigger. So when I add more and more terms of this geometric series, my total over here is just going to get bigger and bigger and bigger. It's going to blow up. It's not going to ever settle on one nice number total. There's a name for that. We're going to say this geometric series diverges, and in fact that's going to happen for any geometric series where my common ratio is more than 1. So then, I know this is the question everybody's asking, what happens if the common ratio is less than 1? Well, here's an example of that down here. My common ratio is less than 1, it's 1/3. So I want to look at just the first few terms here. If I is 1, that's 1/3 to the first power. Oh, I can do that one, that's 1/3. We're adding, see the sigma there. When I is 2, that's 1/3 squared, which is 1 over 3 squared, 1/9. The third term, 1/3 to the third power is 1 over 27, If I multiply that again by 1/3, I get 1 over 81, and so on down the line. And if you notice, each consecutive term is getting smaller now instead of bigger like with the other one. My terms are getting smaller and smaller and smaller. When that happens, when my common ratio is less than 1, we actually can add up all of the terms of this geometric series. Even though there's infinitely many of them, there's the infinity there, there's infinitely many terms, but since my common ratio is less than 1, my terms are getting smaller and smaller, and we can actually get a single total for these infinitely many terms. There's a word for this too. It's converges. And that happens when my common ratio is less than 1. If my infinite series converges, the formula gets a little simpler. It looks like this. I still need A1, the first term in the sequence. I still need to know the common ratio R. Let's do that for this one. A1, oh, conveniently we already found it. It's 1/3. So I need 1/3 divided by, I think we need some parentheses in there. It's going to do something I wish it hadn't, so we'll just slide those in there. I'm going to do 1/3 divided by 1 minus, well, my value of R is 1/3. Well, we can't leave it like that. We don't want the complex fraction there. We got to simplify. 1 minus 1/3. I can do that one. That's 2/3. Okay, that's only slightly better. We can simplify that some more. Think of multiplying by the reciprocal, and we end up with a grand total of 1/2. This says if I add up 1/3 plus 1/9 plus 1/27 plus 1 over 81 plus all of the other terms, all of them, there's infinitely many of them, never ending. If I add them all up, I will get a definite total of 1/2, and that happens anytime the common ratio in a geometric series is less than 1.